Well, hello there. It is KP, the Math G, and I'm getting excited about these types of problems that we've been doing. I've been excited about it all along, but I kind of like doing area bounded by, in this case, a line and a curve. And so that's what we want to do. We want to look at the area between these two functions. Okay. The top function is f. The bottom function below it is g. F, as you can tell, is a straight line. We know that from way back, don't we? That this is a straight line. This is a parabola that opens upward, or we might say in calculus is concave up. And so I've already drawn the graph for you. Now, on probably a free response question, one may ask, well, where are the points of intersection? You can probably obviously see where the points of intersection are, okay? But let's find them anyway. Let's go through all the process that you would do if you were taking a free response exam, okay? So let's go ahead and get started with this. Let me use this color right here. Alright, now, if you want to find where two functions intersect, you have to set those functions equal to each other. Doesn't that make sense that we set them equal to each other? So I want to set g at x equal to f at x. Now you could have turned that around and said f at x equals g at x. That's always how you find points of intersection. Okay. You can draw this out on your calculator, and you can get the intersection points from your calculator. That's all right. But I want to do this by hand. Okay. So let's do this. X squared minus 2x plus 3 is equal to 1x, or just x, plus 3. Alright? You know how to solve a quadratic. Bring everything to one side, zeros on the other side, and hopefully you can factor this. Alright, we're going to do that. So I'm going to subtract 1x on both sides. And I'm going to go ahead and subtract 3 on both sides. Kind of kill two birds with one stone, so to speak. And notice this side here is simply 0. 1x minus x is 0. Alright, 0. And then 3 minus 0, or 3 minus 3 is 0. So 0 plus 0. This side here, 3 minus 3 is 0. Alright, so we're left with negative 2x, negative 1x is negative 3x. We can add those because the signs are alike. And then just simply bring down the x squared. Alright, so we have x squared minus 3x plus 0 equals 0. Or we can just simply say x squared minus 3x equals 0. And then, of course, we know what to do from there, right? Well, we factor out an x. That's right. Factor out an x. Alright, so we're going to do that, and we'll factor that out. I like to just divide. That shows exactly what I'm doing. Not going to do it on this side either. I don't want to get rid of x altogether, okay, because we are factoring out an x. Alright, take 1 out, you have 1 left. Alright, so 1 plus 1 is 2. And then minus, these x's are gone. Alright, so, okay. Alright, and actually, in all actuality, you just factor out the x. X times x is x squared, x times 3 is 3. X times negative 3 is negative 3. X, okay. Alright, now, there's a product rule that says that if A times B equals 0, then A is equal to 0 or B is equal to 0, and that's what I want to do here. Alright, X is equal to 0 or X minus 3 is equal to 0. We know what one answer is. X is equal to 0. We can look at this and visually see what this is. Add 3 to both sides. You really probably don't need that step, but if you need it, that's fine. This is gone, and so X is equal to 3. Okay, alright, so I know where my X components are. X is 0 or X is 3. Alright, so let me erase this. We're going to need this throughout. Oh. Alright. Alright, I know that my X values are 0 and 3. Okay. Alright, so now let's go ahead and erase this too. Alright. So now I can simply plug them in and see, and I picked the easiest one is this one. Doesn't matter because you've got the intersections on both of these, so just find the easiest one. F at 0 is equal to 0 plus 3. This is actually the same thing as saying Y is equal to 3. Okay, F at X is the same as Y. Alright, so Y is equal to 3. So the point of intersection on this one is 0, 3. Alright. And then the other one, I can plug it in. F at 3. And then again, 3 plus 3 is equal to 6. Alright, so F at 3 is 6. So that's Y is 6. Alright. And again, so here we go. This is 0, 3 right here. 0, 3. And then this one here is 3, 6. Alright. And of course you have to draw the graph of each one if you did. Okay. Let me erase this again. I want to try to keep everything on one side. I don't want to have to flip the board over if I can possibly help it. Alright. Now again, you can draw this. You already know where the points of intersection are. Just 0, 3, 3, 6. Draw the line straight through. And then the curve. How do I know it goes down to here? Well, 1, 2. Alright, 1, 2 is that point of intersection. The X value of the vertex can be found by negative B over 2A. When we consider that 1 is A and B is negative 2, then I can just substitute X is equal to negative 2 over 2 times 1. And that is 2 over 2, which is 1. That's my X value. To find my Y value, I can just simply plug it in. So G at 1 is 1 squared minus 2 times 1 plus 3. So 1 squared is 1. 2 times 1 is 2, so minus 2 and plus 3. This is negative 1 plus 3, which is equal to 2. Alright, so the vertex is at 1, 2. And just simply draw that graph like that. I know that it opens upward because the number in front of X squared is positive. Okay. Alright, so there it is. Alright, let me erase that because we're going to be doing a lot of erasing because we're going to need all of the board. Alright, we might not even need that point there, but we'll worry about that later. Okay. Alright, points of intersection. Again, You can put y1 in your calculator, y2 in your calculator, or reverse that, either way, and you can see, you can find points of intersection that way. And right now I'm not going to take that time to show you, but if you want a video on that, I will definitely do that for you. Okay, now here's what we want right here. Okay, I don't need that point there either. I want to find this area right in here, don't I? All of this area between the two functions right here. I want all of this area. Okay, like that. Alright. So here's what I'm going to do. There is a rule that says that if I know what my limits of integration are, well, in this case we're going to say a to b, and be aware which one is on top of the other. F is above the g. The f function, which is here, the straight line, is above the g function. So we say the above function is going to be subtracted minus the below function. That is true everywhere. Okay? That is true everywhere. Okay. So let's just look at this. This, by the way, is, we can say, alright, we can, in this case here, we would say that we're going from, well, I'll talk about the integration in just a little bit, alright, but we see that F is above G, and well, let's say for right now from A to B, and dx like that, okay, like that. The F function is clearly above the G function. Had it been the other way around, that this function had been over the top of this line, then we would have said G minus F. In this case, F minus G. And I want to show you why that's so. Okay? So let's get a partition here. Let's start it at F. And let's go down. Okay, like that. This value right here, this distance right here, from here to here, I got to write it off to the side. I don't want to mess up the picture any more than I have to. Okay, right there. This height right here, from here to here, is y, we'll say y1 or y2, it doesn't matter, y2. What is that height? This right here that touches this pink line, F, is this height right here. These represent height. So we could say that y1 is equal to x plus 3. The height 1 is y1 height. We'll just say the height of G, of the G function, the F function rather. The height of F. Let me write this where it can be more readable. Alright, the height of F is alright, given by, well, y is equal to, this y2 is equal to F, which is x plus 3. That's the height right here. So in place of, well, I'm going to show you this height here. Now, why do we subtract here? Why do you think we are subtracting? What are we subtracting off? Well, I'm going to show you. Okay, I might leave this up here. I want to erase this. I'm going to show you. Let's get a different color. Let's see, maybe this. I already have that color. Let's use red. This is fine. Okay. G is right here. This height is G. Okay. This height from here to here is G. We'll call that Y1. Alright. So the height of G is Y1, which is x squared minus 2x plus 3. This is empty space here, isn't it? There's nothing here. There's no graph here. We want the area between this line and this curve. I want actually this height here. I want this height right here. We'll call it, say, Y3. Okay? I want this height. This is the height that I want. Okay, like this. I want this to be Y3. Let's think about it now. Y3 is the entire height. If I could somehow get rid of this up here, down here, I will have this right here. Well, how much is this height here that I'm crossed out? It is Y1. So Y3 is the total height, which is Y2 minus Y1. Does that make sense? The entire height minus this height here is this inside here. Well, my subinterval will be inside, in between the two functions. Okay, so the entire height is F. This height here is G. So F minus G. That's what I'm doing. Okay. All right. So let's put it up here, and we need to see what that interval is now. I want this portion right here, since I'm erasing this. Okay, I don't want that. I want to get rid of that height. I just want this right here. Oops. Right there. I just want that right there. I'll put this in dot. Okay, we'll dot it. Alright, like that. Alright. I want this height gone. This minus this is this. F minus G is F minus G here. That's what it is. Okay? So, here's what I'm doing. So now, I'm ready to set this up. Now, I want my limits of integration. From where to where? This thing can go all the way over. This interval could be way over to 0. Low as 0. As far up as we can go, blah, 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 until we get to x equals 3. So this interval could have been way up here at 3, or way over here, right down here, 0, right? So from 0 to 3, this way, from 0 to 3, there it is. I'm not taking the y value. That's a different lesson. We're not going from 3 to 6. I'm looking at the x value. If this subinterval is perpendicular to x, we're going to look at x. If this interval is perpendicular to y, we're looking at y. And the next lesson is going to be dealing with y. But here we got f. All right, we're looking at this. Okay. Anyway, we're looking at this portion right here. Now, what is f at x? It is x plus 3. So, 0 to 3, x plus 3, we're going to take away the g minus the g that we don't need, as one whole, block it off, and this is dx. Now that is part of the battle, knowing which one to do. Now, if all else fails, remember the rule that the top minus the bottom. If you don't understand this completely, it is the top minus the bottom. I don't care where it is. It could be way down here below the x-axis. It's still the top minus the bottom. If f is still on top, over the top of the g function, then it's still f minus g. That's it. That's all you have to remember about that. So just keep in mind, this is what you have to do. Now, we got a little arithmetic to do. Okay. Alright, so let's erase this. Alright, we're just going to be moving back and forth, up and down. So bear with me. Thank you for tuning in and bearing with me. Somebody may say left and right. Well, eventually we will have one going this way, left and right. That's the next lesson, so be patient. It will come. I will give you that. I promise you. It's not going to be a line and a curve. It could be two curves. It could be a line and a curve, but I'm just going to do two lines, okay, for the next lesson. Alright, so here we go. This is f minus g. Let's do a little cleaning up a little bit. So this is 0 to 3, x plus 3 minus, okay, let's distribute the negative sign. So minus x squared, I don't need to proceed here, minus x squared plus 2x, okay, minus 3 dx. Now I think I can still do some work here. 3 minus 3 is 0. So I'm left with 1x plus 2x. I'm left with 3x minus x squared. And then dx. Now, did I do that right? Minus x squared plus 2x minus 3. 3 minus 3 is 0. 1x plus 2x is 3x, and then I've got a minus x squared here. We just have to be careful with our signs. Everything looks good. Okay. Now, let me erase, because we're going to need room. But we have made it look a little bit smaller, haven't we? That didn't always work that way, but this is really nice now. So I'm at a point where I can integrate, can I? You know how to do this. You know, the problem is f minus g is this. You get that concept in your mind, especially when you get ready to revolve something around an axis. Yeah, we're going to do that too. We're going to revolve this way and we're going to revolve this way. Alright, so get ready for that. That's coming. Have you done that yet? Well, if not, I'm going to be the one to supply that for you. And if you have, it's good review. I can integrate this, can't you? Okay, so this is, let's get another color, let's get this. So now this is 3 equal to 3x squared, add 1 to the 1, that's going to be a 2, that's just the way it works, guys. Then divide by that 2, that's the way it works right there. Add 1 to your exponent, divide by that. Okay, minus sign. Now add 1 to 2, we get 3. Okay, so 3, and then divide by 3, and I'm going from 0 to 3. Hey, man, that's pretty nice, isn't it? You think you can go from here? I think you can. I think you know what to do, right? This is again F at 3 minus, or the integral at 3 minus the integral at 0. So here we go. 3 times 3 squared over 2 minus 3 cubed over 3 minus, well, now if I plug 0 in both of these, what do you think I'm going to get? Now that's one big 0, but let's plug it in anyway. So 3 times 0 squared over 2 minus 0 cubed over 3. For those of you who are taking the AP exam, I don't know if you need to show this or not. You might, at the very least, you might just put a big 0 there, but ask your instructor which way that needs to go. Do we need to show this or not? Okay. Okay. All right. Let's get to business here. The calculus student, anyway, this is a good thing to do here. All right. 3 squared is 9. 9 times 3 is 27. So we have 27 over 2 minus 3 cubed is 9. 3 cubed is 27. 3 times 3 is 9. 9 times 3 is 27. So 27 divided by 3 is 9. Okay. So, and then minus, this is 0. This is 0. 0 squared is 0. 0 times 3 is 0. 0 over 2 is 0. 0 cubed is 0. 0 over 3 is still 0. So that's all 0 there. If I have x's in both of my terms and y'all got a 0 here, all of this is going to be 0 anyway, right? Alright, so now let's figure it out. I have this point 27 over 2 minus 9. Alright, now remember 2 times 9 is 18. Alright, so 18 over 2, that's another way of writing 9, right? Okay, so 17 minus 8, that's 9, so 9 over 2. Now this area is 9 over 2. Again, when we integrated, alright, we likely, this is probably not exactly going to be in terms of, say, well, it could be. This definitely, these two represent what am I trying to say here? It is a rate of change. A rate of change. How fast or something. But then when we find the area, remarkably, we're finding, okay, now how much? And I say it over and over, and I use water going through a pipe every time. How fast is the water? Okay, now, in this case, how much water is in the tank? And again, this 9 over 2 could represent, or actually 4.5, if this is in gallons, 4.5 gallons is how much is left in the tank. How much gas is in the tank? Well, 4.5 gallons maybe. Alright, whatever. But anyway, this area that you find represents, if this was a rate, and it is, the rate is going to change into something else. Okay, that's what happens when we integrate. That's just the way it works. This is an area here, all right? So that's what we would do here. I'm just saying that this could represent an amount. Okay? All right. Well, anyway, I hope you get it right here. All right, F minus G. Again, had it been the other way around, G minus F. But still, no matter where it is on the graph, if F is above G, F minus G. Okay, and that's what we did here. All right, after we integrated with that part is easy. I bet you could do that. But just getting it set up right here, that's what we need here. And getting these numbers here straight. From 0, x equals 0 to x equals 3. Okay. I hope that has helped. Again, if you would like to subscribe, I appreciate you doing that. If not, that's okay. I just want you to learn. Okay, and if you have a comment you'd like to make, please comment on